Today we're going to be discussing relations. First, to define relations. A relation is a set of ordered pairs, and a relation can be described in several ways. It can be described as a list of the ordered pairs, by a table, or as a graph. First, representing this as a table. An example would be two sets of numbers, which I'm going to call x and y. And describing this as a table, it shows two sets of numbers where there's a correspondence between the members of the first set, the x values, and the members of the second set. So there's a correspondence where x is 0, and that's assigned to 2, and on. And relation is a broader term than function, which we'll discuss shortly. So the second way to describe this relation would be as a set of ordered pairs. Each set of ordered pairs is shown in parentheses within a set of braces. So the first set is 0, 2. The second set is 1, 3, 2, 4, and finally 6, 8. So this describes the relation as a set of ordered pairs. I can also graph these ordered pairs since each pair describes a point in the coordinate plane. My first set of points, my first coordinate pair, says that x is 0 and y is 2. The second pair, x is 1, y is 3. The third pair, x is 2, y is 4. And now the fourth pair, x is 6, so that's going to be about here, and y is 8. So somewhere up here. Notice that I am not connecting these points and making them a line, because I don't know for sure that they do connect or what's in between here. The entire relation is just given as these 4 points. So in this situation, the graph is a set of discrete points. The domain of a relation is a set of values of the first element of the ordered pairs. The range of a relation is a set of values of the second element. For example, if I have a relation given as the set of ordered pairs -2, 4, -1, 3, 0, 2, and 4, 8, the domain would be all of these first values, or the x values. I can list out the domain in a similar fashion, now just with all the first values. So -2, -1, 0, and 4. That describes the domain. The range, again, is the set of values of the second element. So my second element, those are my y values. Looking up at the relation that I was given, that would be 4, 3, 2, and 8. A domain or range can also have be broader. For example, the domain can be something like all real numbers. So not in this case, but just in another case, it could be all real numbers. Or a domain could be given as, x is greater than 3 but less than 8. The same with the range. It could be all positive integers. So these are some examples of domains and ranges that you could see. And up here, we were just given a specific set of ordered pairs, so it's a very limited domain and range. The inverse of a relation is the set of ordered pairs in the original relation, but now with each ordered pair in the reverse order. So the domain becomes the range, and the range becomes the domain. Looking at an example to illustrate this, given a relation 1, 2, 3, 5 for our second pair, 8, 10, and 10, 12. My domain is 1, 3, 8, and 10. My range is 2, 5, 10, and 12. Now, if I were to write the inverse of R, what I'll do is reverse the order. So each second value, each Y, becomes the X, and vice versa. So for my first pair, instead of 1, 2, for my inverse of R, the pair is going to be 2, 1. For the second pair, 5, 3. The third pair, 10, 8, and so on with 12, 10. So the inverse relation switches the domain and the range. Now, applying what we've just discussed to some examples. Let the relation R be, and we're given a set of ordered pairs for this relation. And we're asked to represent R as a table and a graph. First, as a table, my first set of elements I'm going to assign as X, and then the second element, those are going to be my Y values. So I look through each first element and I write those down. 1, 3, 0, -2, and -1. For my second values, I'm going to have 4, 7, 6, 3, and -7. So that is this relation represented as a table. In order to represent it as a graph, I go over to the coordinate plane and I just plot out these points. 1, 4, that's telling me that X is 1, and I go up to 4 for Y. So that's 1, 4. The second is 3, 7. So 7 is going to be about up here. So 3, 7, 0, 6, 0, 6, -2 for the X value, -2 for the X value, and then 3 for the Y value. And then finally, -1 for X, and then -7 for Y. So -1, and then down here at -7. Again, I am not connecting these points. This relation is a set of discrete points. I don't know if they connect, how they connect, if there's any points in between. All I'm given are these sets of pairs. Therefore, when I graph them, I'm just going to get 5 discrete points. The relation R is described by the following table. Find the domain and the range of R. In order to find the domain and the range, I'm going to look at my first set and my second set. And I could actually first write these out as a set of coordinate pairs. So this would be -2, 3, -1, 7, 0, -1, 2, 4, 6, -6, 10, 8, and then finally 15, 3. So I have this written out as a set of ordered pairs. It's a set of ordered pairs, and I'm asked to find the domain. Well, the domain are going to be the members of the first set, the X's. And that's going to be -2, -1, 0, 2, 6, 10, and 15. The range, that is going to be all the members of the second set of values. 3, 7, -1, 4, -6, and 8. And then I notice I have 3 again. And I don't need to list that twice. I have 3 represented here. That's a member of the range, and I only need to represent it once. So this is going to be my range. The relation R is described by the following ordered pairs. So I'm given a set of ordered pairs. Represent R as a table and a graph. Find the domain and the range. First, representing R as a table with X and Y for my first set of values and my second set. So I have -2, 7 from my first set of ordered pairs. The X is always listed first and then Y. 3, 6, -4, -8, 0, 1, 2, 6, and finally 5, 7. So I've represented the relation as a table. Now I'm asked to represent it as a graph. Again, I've been given a set of ordered pairs, so this is going to be just points on the coordinate plane, discrete points, 6 discrete points. -2, 7, so -2, and then 7. So add on just a bit. That's my first point. Next point is 3, 6. So 3 on the x-axis and then 6 on the y-axis. Next, -4, -8. So we'll put -8 right there. -4, -8. 0, 1. 0 for the x, 1 for the y. 2, 6. So 2, 6. And finally 5, 7. And what I have here are 5 discrete points, so that is my graph of this relation. The domain is going to be my set of x values. And I have -2, it's easier to look at it in the table form, 3, -4, 0, 2, and 5. For the range, I have 7, 6, -8, 1. Well, I already have 6 listed. If I listed it again, that would be fine, but I really don't need to. And then 7. I already have 7. So my range is actually only these 4 unique numbers. I don't need to list numbers twice. So I represented the relation as a table, as a graph, and I found both the domain and the range. Okay, in example 4, the relation R is given by the following table. Write the inverse of R as a list of ordered pairs. And find the domain and the range of the inverse of R. Remember the definition of the inverse of a relation. You switch the values of the first set and the second set, or switch the domain and the range. So this is R, and in R I have the domain given here and the range given down here. So for the inverse of R, I'm going to write this as a set of ordered pairs. However, now my y values will become my x values, and the x values will be the y values. So instead of writing the ordered pairs -3, 2, -2, 6, I'm going to write it the opposite way. 2, -3, 6, -2. Okay, so I have 2, -3, then 6, -2, -3, -1, 4, 0, 7, 2, 9, 3, 11, 5, and right down here I will put 4, 6. So my inverse of R is this set of ordered pairs, where now my first set of values was the second set of values in the original relation. I'm also asked to find the domain and the range. First, the domain of the inverse of R. So that's going to equal these first values in my inverse of R. I'm not going to look back up here. I'm going to look at my new set of ordered pairs. 2, 6, -3, 4, 7, 9, 11, and 4. Okay, so this is the domain of the inverse of R. The range of the inverse of R is equal to my second set of values. -3, -2, -1, 0, 2, 3, 5, and 6. So this gives, as I was asked, the inverse of R, the domain of the inverse of R, and the range of the inverse of R. That concludes this lesson on educator.com.